Okay, so yesterday we talked about multiplication properties of exponents, and today we're going to talk about the division property of exponents. To divide two powers with the same base, subtract the exponents. So yesterday when we multiplied, we added the exponents. Today we're going to subtract the exponents because we're dividing. For any non-zero number a and any integer m and p, you would have this example. A to the m over a to the p would give us a m minus p. Now pay attention that you always have to put the numerator exponent first and then the denominator exponent. Let me cover this part up here. All right, so the first example, you have c to the 11th over c to the 8th, which would give you c 11 minus 8, which gives you c cubed. The next example is r to the 5th over r squared equals r 5 minus 2, which is r cubed. All right. Now the next thing you need to do is you need to group your powers with the same bases. So make sure that we still group all of our bases together. And just like in multiplication with division, you're going to have to separate all of your bases together. So let's look at the first example here. G cubed h to the 5th over g h squared. So I'm highlighting the same bases with the same color. So I have g's in yellow and h's in orange. So when I talk about separating, I'm just going to write it g cubed over g1. Because you'll always, if it doesn't show the exponent, you have an exponent of 1. And then we have h to the 5th over h squared. Now that brings us down to this part, where now we're just going to subtract the numerator exponent from the denominator exponent. G, 3 minus 1, and then you have h, 5 minus 2, which is going to give you g squared, h cubed. Okay, so now let's look at example 2. Okay, I'm just going to let y'all see that and we'll go through it here. All right, so the example here is we have x cubed y to the 4th over x squared y. And we're going to separate our x's. So we have x cubed over x squared, y to the 4th over y. And there's that to the first power right there. So now we have x, 3 minus 2. And y, 4 minus 1, which is going to give us x, 1, y, 3. And you don't have to have that 1 there, so you just have x, y cubed. So now let's talk about the power of a quotient. Okay, power of a quotient. To find the power of a quotient, find the power of the numerator and the power of the denominator. Okay, power of a quotient. So this is what it looks like. If you have a over b to the m, we're going to distribute your exponent m to the numerator, and then we're going to distribute the same exponent to the denominator, okay? So it actually gives you a to the m over b to the m. Okay. All right. So your first example, if we have 3 over 5 to the 4th, and I'm actually going to use numbers so that we can kind of see what we're looking at right here. You would have 3 to the 4th over 5 to the 4th. And later on, what you're going to do in your calculator, you're going to say 3 to the 4th equals whatever, and then 5 to the 4th equals, and you're actually going to divide it out because they're numbers, and we don't have any variables in there, okay? But I just want to get y'all in the habit of writing it correctly. So we're going to draw those squiggly lines here. All right, another one is if you have variables, you would have R5 over R2. If they tell you to do the power of a quotient, and there's not that extra parentheses around it, you're going to do what you already know, which is R5 minus 2, which is R cubed. Okay? So if you don't have that extra exponent on the outside, just continue to do what you learned a second ago. All right, so let's do example 1 here. Open parentheses, 3p cubed over 7 squared. 3p cubed over 7 squared. That's a 3. Now what I'm going to do is I'm going to distribute my exponent. What I want to do is I want to break up my numerator, and then I want to break up the denominator by itself. What do I mean? It looks like this. 3p cubed squared over 7 squared. Do you see how I did that? I just took this square and I left it here with that set of parentheses, and then I just brought it down here. All right? So then I'm going to separate, okay? Because remember, now we have to go back to our multiplication rules, right? So this 2 now has to be distributed. So I have 3 squared, and then I have p, 3 times 2 or plus 2?
Plus 2.
Times 2. Over 7 squared. And what is 3 squared? 9. And then I have p, what's 3 times 2? 6 over 49. So that would actually be the answer to that problem right there. And that's simplified in your simplest form. Okay? I cannot do anything else. I don't have the same basis, and we're good right there. All right. Example 2. See if I have room to do this one. 5x to the 5th over y, times y over 6 squared. So 5x to the 5th y over 6, and the whole thing is squared. And I'm going to go ahead and work down since I don't have enough room over to the right. So we're going to separate this. 5x to the 5th y squared over 6 squared. Once you do that, it makes the problem a lot easier. So now I have an exponent on the outside. What do I do with this exponent? We're going to distribute it. So we have 5 squared, and then you have x 5 times 2, and then you have y squared. 1 times 2 is 1. 1 times 2 is 2, so you can just write it down. All over 6 squared. Okay. 5 squared is 25. 5 times 2 is 10, so I have x to the 10th. And then you have y squared. 6 squared is 36. So you just have to make sure that you are separating everything out.
Why don't you distribute the